Today's lesson is going to be talking about the difference between distance and displacement. Now, before we can explain the difference between distance and displacement, we have to understand what the difference between a scalar quantity and a vector quantity. A scalar quantity sounds something like a scale. A scale, for example, could weigh for a certain amount. I could get on a scale and say, hey, I weigh 150 pounds, and that would be just a number. A vector quantity, however, doesn't just have a number, it also has a direction. A vector is another name for an arrow. Arrows not only have a size, this arrow, for example, could be 2 units long, but it also has a direction. In this case, it's pointing to the right. This arrow would represent 2 units to the right. Whereas a scale doesn't have a direction. Scalar quantities have number only. Now, when we're talking about motion and how things are moving, we can talk about how fast in terms of, or which way or how much in terms of just a solid number. But we can also talk about in which direction. Direction is really important in physics. It makes a big difference if we're heading east or west, if the temperature is positive 30 or minus 30. Anytime we're talking in science, it isn't just the amount that matters, but the direction that is involved. And there's lots of ways we can describe direction. We can talk about positive or negative directions. We consider directions to be positive if, for example, on a compass, we're going north or east. We also consider directions to be positive if, for example, we're heading up or to the right. We can also talk then about directions being negative. Directions are considered to be negative if on a compass, for example, we're heading south or west, or if we're moving in a direction of down or to the left. We can get the idea of positive and negative numbers even from our understanding of a number line. Picture a number line with 0 in the middle, and then we're numbering from 1 to 10 as we move towards the right. These are all positive numbers, and any direction moving towards the right is considered to be a positive direction. Likewise, as we move towards the left, these are negative numbers, and moving towards the left is considered a negative direction. On our compass, again, anytime we are moving north or east, we are moving in positive directions. If we are moving south or west, those would be considered negative directions. And on a thermometer, if we are going up and the temperature is increasing, that's considered to be positive, and if it is going down or decreasing, that is considered to be negative. So we can use positive or negative signs in science to indicate the direction of movement that we are discussing. So let's come back to our understanding of distance and displacement. Distance is going to be a scalar quantity. It tells us how far we've gone, but not necessarily which way we went. The distance covered by the red line on this ruler is 3 centimeters, but it doesn't say whether or not I drew the line from the left or from the right. In order to know the direction that movement happened, we would use displacement. Displacement is a vector quantity. I could, for example, say that when I drew this line, I moved 3 centimeters to the right, or I would say that I had moved positive 3 centimeters. Displacement can be a little confusing at first. Imagine you go for a walk and you walk 2 kilometers from home. Let's mark our location of home as being right here at 0. If I'd walked 2 kilometers, I've walked 2 kilometers away in this direction. If I now turn around and walk 2 kilometers back, I've walked 2 plus 2, or 4 kilometers, but I've ended up back where I started. My displacement is 0. From my starting point, it appears that I haven't gone anywhere at all, although my total distance shows that I've walked actually quite a long way. Distance is always calculated by adding together all the distances that an object's covered. If I walk 2 meters east and then 2 meters west and then 2 meters north, I would have walked 2 plus 2 plus 2 is 6 meters. Distances are always positive. You can't walk -5 or -6 meters. You would have covered a certain amount of distance. My displacement's a different matter altogether, though. To figure out your displacement, you have to look at the difference between where you started and where you ended. Consider this number line. We're going to call my starting point D1. It's the first place I was. We're going to call the end point D2. It's where I finished off. D1 is what I call my starting point. D2 is what I call my end point. In this picture, we can see that my start point is at +5. My end point on the number line, my finishing point, is -3. So -3 is my D2. To figure out how far that I have moved, I'm going to go D2 minus D1 is equal to my change in displacement. Now, change in displacement is a lot of words, and so we quite often use this little triangle symbol, which means the change in. It's actually the Greek letter delta, and it stands for change in, as how has something changed over time. So my D2 was -, and from that we're going to subtract my D1, which is +5. So -3 minus +5 is equal to -8. So this is one way that we could calculate how far we've moved. I've moved -8. I've moved 8 spaces in the negative direction. Now we can count this also just on our number line. You could go ahead and mark your D1 at position +5 and your D2 at position -3, and then you could count how many spaces you've moved. You've moved 1, 2, 3, 4, 5, 6, 7, 8 spaces in the negative direction. We've been moving to the left. 8 spaces in the negative direction is -8. In this diagram, which we tried to draw in 3 dimensions, we see a person walking from point A to point B and then point C. They move from the tree to the house to another tree. The original path from the tree to the house was 4 meters, and they're attempting in this picture to draw it straight north. They then traveled 3 more meters due east. These are both positive directions. So they've traveled a total of 7 meters in distance. Their displacement, however, is much less. Using the Pythagorean theorem, you could figure out that their displacement was only 5 meters. Now, we have to give this a direction as well. And using a compass, we can see that we have moved in a northeast direction. So they have moved, or have displaced, 5 meters to the northeast. Now, our first task is going to be to complete task 1 in your workbook, which is the treasure hunt. And we're going to have to make a couple of changes for those of us working at home. In your motion workbook, you will notice task 1 asks you to find a little bag that's going to be full of popsicle sticks. And we're going to have those popsicle sticks cut to varying different sizes. I'm going to get you guys to use anything you can find around your house to substitute for popsicle sticks. Find a bunch of different sizes. You can use some straws that you've cut up to different size, or maybe some old chopsticks that you might find lying around from an old food order, or anything really that you can find. You might even want to cut different little pieces of tape to different lengths. And what I want you to do on each one of those lengths is write the size that they are, whether they're 2 centimeters or 3 or 1, and assign each one of them a direction. You could assign them to be north, south, east, or west, or if you wanted to, you could even pick some angles and say that we're going to go northwest or southeast. We're going to try and keep our directions reasonably simple. What I want to do is then, once you have a bunch of different lengths, I want you guys to take a look at the discussion here where they're talking about your grandmother hiding her treasure. And she has all of these different lengths beside an oak tree. And what you have to do is see if you can figure out whether or not it matters which order you put the sticks in. So I'll get you to take a big piece of paper and draw a tree on that piece of paper, or put an X. That'll be your starting point. You'll then have a variety of different sticks of different lengths. Each stick will be numbered with its size and the direction of motion. For example, this could be 2 centimeters moving north. This stick might be 1 centimeter south. In my examples, I also have 2 centimeters east and 3 centimeters southwest. I want you to try putting the sticks together in different orders and calculating the displacement. So, for example, you might want to start from your starting point and move 2 centimeters north. So you can pick up your sticks and move 2 centimeters from your starting point north. You might then try adding the 2 centimeters east and moving those ones over, followed by 1 centimeter south, and then the 3 centimeters southwest. Of course, you're going to be using your own sticks. Once you've done that, you're going to find your end point and you're going to mark an X at that location, the point where you ended. I'd like you at this point to calculate how far is your displacement. Remember, your displacement, as I've shown you here with my green arrow, is the difference between where I've started and where I've ended. It will have a size and also a direction. Once you've done this, I'd like you to try this by arranging your sticks in a different order. Try maybe using one of your other sticks first. See if you can get to different locations or if you always end up at the same location.